if we think about what aqueous means, it means you're going to dissociate. So really, what I have is I have an Na bonded to a Cl3 bonded to an Na, or another one. Do you see how that is? How Na2Cl3 is actually this? Please tell me you can follow this.
Yes.
Okay? So when I dissociate this, I am getting rid of this bond and this bond. So I end up with an Na plus a Cl3 minus 2 and another Na plus. That's why you have the 2 there, okay, and we don't put the 2 there. So if you would have looked at the amount of things that are being produced, this is what's happening. I'm making an Na and another Na and then a single CO3. And that's why it's represented with a 2 there and there's only 1 there. So this is what it should have looked like. 2 Na plus 1 aqueous plus Cl3 negative 2 aqueous plus Ca plus 2 aqueous plus 2 Cl minus 1 aqueous. This one is pretty straightforward. Okay. The other side is a little more tricky because this one is a solid, which is easy. Just keep it together. Nothing to do there. But then we have 2 Na pluses, plus 1s, and 2 Cl minus aqueous ones. So when we look at that, this is the one that is missed most often. Because what we have when you look at the equation, right, is CaCO3 solid plus 2 NaCl aqueous. That's what was in the book, or on page 242. This number 2 right here means I have 2 of these and I have 2 of those. So I have to remember, okay, to bring that down there. That is a very common mistake where kids forget to do that. So when you're going through here, things to make sure you're doing is you're putting in the charges, all right? We're putting in the states of matter after, okay? Not below, not above, not before, after. For some reason this year we're just like putting them in wherever we want, okay? That is frowny face. Charge, 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 charge. And then if it's a solid, a liquid, or a gas, we leave it stuck together. And then remembering to transfer, okay, those coefficients. There's a lot going on here. Now, with this one, if I said, hey, give me the net ionic equation, well, what we do is we go through and we get rid of all the spectator ions. Spectator ions, like you said before, are the same on both sides. So here I have 2 Na plus 1s that are aqueous, and here I have that. So I'm going to cross those out. That's a spectator ion. Cl3 negative 2, I don't have that over here. Ca plus 2, I don't have that over here. 2 Cl minus 1 aqueous I have on both sides. So that's another spectator ion. So if I said, what are the spectator ions? You would write Na plus 1 and Cl minus 1. You don't have to put the 2's in front. If you did, it'd be fine. Make sure you have the charges because it says spectator ions. And then the net ionic is whatever's left over. Okay? So I have that, and I have that. So my net ionic would be CO3 with a negative 2 charge aqueous plus Ca plus 2 aqueous yields CaCO3 solid. On an assessment, if we're going through, more than likely, I'm going to ask you, it could be very difficult. I could just give you the first 2 compounds, which you're going to see in the worksheet is what you do. Okay, but I'd be looking probably for a point for the balanced equation, a point for the correct complete ionic, maybe an extra point for putting all the correct charges in states of matter. You know, there's another point, there's another point. This would be a 5, 6, 7 point question, just one question like this. So, and you're going to lots of practice in your worksheet. So, I think we have time, why don't we try one more in the class? So on page 243, why don't you do letter B, number 28B? Give that one a shot. Okay, so the equation is up here. It's also letter B. The first thing you got to do is go through and balance. So you should have ended up by putting a 3 in front of the NaCl aqueous on that side. So we're going to walk through this. Again, these take a lot of space, so you might have to write a little smaller. We will have 3 Na plus 1 aqueous plus PO4 negative 3 aqueous plus Fe. You should have hopefully figured out that's a plus 3 charge. If you didn't, that's old stuff. You would do this, the box thingy, right? To figure that out. Oops. Plus 3 Cl negative 1 aqueous. Right. This is a tricky thing to remember. And that one there, you gotta move that over. Yields 3 Na plus 1 aqueous plus 3 Cl negative 1 aqueous plus FePO4 solid. So that is the complete ionic. Anything that's aqueous, we break apart. I broke that one apart. I broke that one apart. I broke that one apart. And then this one stayed together because it's a solid. If it was a liquid or a gas, same thing. You keep it together. Now, net ionic. We need to figure that out. Well, one thing you can do before we even do that is you can figure out your spectator ions. Sometimes I ask for them, sometimes I don't. So I'm going to say, what are the spectator ions? Well, we go through and we cross out whatever's aqueous on both sides. 3 Na aqueous on both sides. So one of them is going to be an Na plus 1. And the other one is going to be 3 Cl aqueous. So there's my spectator ions. Whatever I have left is my complete ionic. So, or my net ionic, I apologize. So net ionic. Making sure that we keep the charges in there and the states of matter. And we are done. So this right here would be a complete, that's my complete ionic. This could be my skeletal equation. This would actually be a balanced skeletal equation. So maybe, for example, on the assessment, the question that I give you is aqueous. I'm going to shorthand this so I have enough space. Sodium phosphate reacts with aqueous iron 3 chloride. Okay? So this could be a great example of an assessment question right here. You would first need to write out the skeletal equation and then balance it. So that's probably 2 points right there. 1 point for the skeletal equation, 1 point for balancing it. Next point, complete ionic. I want you to break that whole thing apart. That's worth another point, maybe even 2. Maybe I give you a point for breaking everything apart and another point for putting the proper charges and states of matter in there. So up to 4. Identify the spectator ions. Give me the net ionic equation. So I'm up to 6 points for one question. Okay. This stuff here, you already know how to do. So where our last assessment was on. Right? You just flip-flop them. Snap ions are important. So that is like the hardest the question could be right there. And what would really make it even more difficult if I just said this and said, give me the net ionic. That's all I want. So if you could look at this and tell me what the net ionic is and give me that equation, that would be fine. All right? You're probably going to want to go through a lot of this, though, at the beginning. So on the worksheet, you can see that I gave you a lot of space for all that. All right? I will also say that I messed up on one of them. Or 20. If I don't give you the charge of a transition metal, just assume it's 1. We'll just make our lives easy. I forgot to put those in for a couple. And all of these should be assumed to be aqueous. So like number 27, it says sodium sulfate plus barium nitrate. Assume those are all aqueous for this. All right. I thought I put that in there. Apparently I did not. So there it is. Any questions?